So to turn the machine from an Izod machine to a Charpy machine, we need to do two things. We need to install a set of anvils on the base of the machine. Now these can be installed permanently to remain in place. As I stated earlier on, you cannot install both of the ISO and ASTM anvils at the same time, as they occupy the same space on the anvil here. So you can't install both of those. But we can run Izod and Charpy on the same machine, but we do have to change out the striker and set the anvil spacing. So to change the striker, we take our Charpy striker that we see here, which is going to mount in this location. To change out this striker, we need to undo the two bolts that hold the Izod striker in place. Now the Izod striker is also pinned and is a very, very tight fit. So certainly on new machines, you will find that this can be quite a struggle to get off and does take quite a little bit of effort to remove. What I typically find helps is leaving the two bolts in the striker, then holding the pendulum. If you push back, you'll actually be able to push the striker out of the pendulum, leaving it just held by the bolts. If you remove the bolts, you often struggle to get it out because you're trying to fight the pin and the tolerancing on the striker. Fully remove the bolts, remove the front plate, and you will find that you can remove the striker quite easily just simply by sliding backwards out of the pendulum. You then take your Charpy striker, and this also has its own clamping plate. Take care when placing the striker that the correct standard is chosen. I'm actually choosing ASTM D6110 for this particular test. Place the striker on the pendulum, place the backing plate, and then reinsert the screws. It is always wise to ensure both screws are inserted before tightening anything to make sure that everything's aligned properly. You'll also notice there is a little bit of motion on the striker. However, with Charpy, this distance here does not matter, and it is shouldered back against the pendulum so it is centered correctly. Make sure these screws are tightened, but do not over tighten them. Once we have installed the striker, we can then consider installing the anvils. I already have one anvil fitted to the vice base here, and I have two anvils here to demonstrate the difference between the ISO and ASTM anvils. You can see that they have different profiles. So obviously, dependent upon the test that you're doing, you would fit the correct anvil. I'm actually going to fit the ASTM D6110 anvil, as that is the striker that I have. It is a T-nut system. You slide it into the vice base and engage it into the vice body, and it fits very snugly with no rotational motion. The next item is our centering gauge that we have. It also has the ASTM D6110 number written on it. The ISO version is much smaller, but it's the same basic idea. The idea with this is we're able to use this as a gauge to set the spacing between the two anvils. So we place it between the two anvils to give us our spacing. The notch where my thumb is actually a centering notch, which we can use the striker on the pendulum to act as our centering. So if we bring our pendulum into play here, we bring our pendulum down and we then take our gauge, we place it within the anvils, and we check the centering of the system. Now you can see this is somewhat difficult to hold. So what we often do is we often take a sample or a ruler and we lay that across our anvils to act as a support, allowing us to place this and get our centering. When we've done that, we can then ensure that our two anvils are centered with the notch matching up with the striker on the pendulum. Once we have them in position, we can then tighten down our anvils, ensuring that they do not move around. Now, obviously, as you tighten them up, you want to ensure that this gauge does not get wedged within the two. So if they does become slightly tight, you would need to slacken off your anvil, move it back a little bit, and then when you tighten it back up and it squares up, you'll find that it goes in. Obviously, we don't want any play, and we need to ensure that it is correctly centered. This is a normal centering gauge that's supplied with every single machine. If you have the anvils fitted, when a technician comes out to do a full calibration on the machine, he would check the centering with a certified gauge to ensure that it's within the tolerances of the ASTM or ISO standard that is required. So this would simply be a basic setup for you. If you are testing, you will also find there's a little peg on the centering gauge. This allows the notch of the sample to engage in the peg to be in the center line of the machine at the same time, so that the center of the sample is in the right location. The sample I have here is about the right length, but it is not notched. But that would mean that when I was placing the samples in, I would be using this gauge to act as my centering on my samples to ensure that my notch was in the correct location. Again, it's a simple piece of equipment that comes with the machine and supplied with it. One point of note, you may have noticed with this striker that it is very close to this notch centering device that you can see here. With the ISO striker, for the ISO 179, which is for the other Charpy, it is a much longer striker, and therefore this notch device would actually get in the way and potentially be impacted by this striker. It is very important that this is removed prior to starting any Charpy testing, and it is wise to remove it whenever you switch over to Charpy testing anyway, as it is not required and removes the risk of impact. These anvils, as you can see, can remain in place even if we return this machine to Izod testing. The Charpy anvils do not interfere with the Izod testing in any way, so there is no problem with, once these have been installed, leaving them in place. It is important that they're kept oiled and lubricated so they do not corrode or rust,